This is the second half of the Geometry 3-7 notes about equations of lines in the coordinate plane. You should have watched the first half of the notes to just talk about basic graphing. We're going to build on that today with these notes now. So we're going to continue to graph and write linear equations. So yesterday you should have graphed two problems. We're going to start off by graphing two more again here. And we're graphing y equals 3x minus 4 and y minus 2 equals negative 1/3 times x minus 4. So these are two different forms, if you remember. This first one right here, this is called slope-intercept. And the second one up here is called point-slope form. Okay, and they're called these because of the information that they have. On the first one it says y equals 3x minus 4. Just a quick refresher, that minus 4 is a negative 4. That is our y-intercept. We go graph that on our y-axis. And then 3, that's our slope. Really remember that that's a fraction. 3 is really equal to 3 over 1. So it tells us we're going to rise 3 and then run 1. So I go up 3 over 1, up 3 over 1, up 3 over 1. And I continue to make these points so I can make this nice straight line. I can go up 3 over 1, but I can also go back 3, down 1. So I will do that as well. And I get this nice straight line here for that first one. Okay, we tried that point slope form. Remember point slope, what we can really do is we can pull out an ordered pair. And so instead of graphing our first point on the y-intercept, we graph this ordered pair. You have your x value and your y value, and they're the opposite of what you saw. So they're 4 and 2, and then your slope is this number up in front. So the first thing I'm going to do is I'm going to go find where the point 4, 2 is. I'm going to put a dot there, and now from there I'm going to graph the slope down 1 over 3. Down 1 over 3, and I start to get this line. Remember, I can take that negative and I can associate it with either of them, so I can move it down to the negative 3, so I can go up 1, back 3, up 1, back 3, and I get this nice straight line that I'm starting to make here. I connect my dots. I've got my graph. Two things to note, please make sure you graph all the way to the edges of your graph and that your lines do have arrows on them because lines are continuous and they never end. So that's a reminder from yesterday. What we're going to do some here is we're going to practice just giving you ordered pairs and a slope and try to write an equation from that. So we can write an equation for a line when we know a point on the graph and just the slope. And so you want to think about the two formulas we've talked about, point slope and slope intercept, and which one fits each situation. So on this first one it says, what is an equation of a line with a slope 3 and y-intercept of negative 5? You're given a slope, you're given an intercept, you should be using slope-intercept form. We're just plugging in our numbers, and I get y equals 3x minus 5, and that's it. We look at the next one. It says, what is an equation of the line through the point and slope? That's point-slope form, so that's this form. And now we just want to plug in our values, so I'm going to plug in my y, my m, my x. And I get y minus 5 equals 2 times x plus 1 is what it becomes because we're subtracting a negative 1, which turns into a plus 1. All right, the video is going to pause here. It's going to stop, and it's going to ask you guys to do these next two on your own, and then you can check your answers with me. Go. All right, you can check your answers up there. Hopefully yours agree with mine. The one thing to note is that every once in a while the directions will then specifically say put your answer in this form. So sometimes when we have a form like this point slope, they'll ask us to change it to that slope intercept form. When we do that, we just want to start solving for y. So one of the things we would start doing then is we would distribute this negative 3 through. So I'm just going to model solving this one for y and getting it into slope intercept, and we would get y minus 4 equals negative 3x. So if I distribute to the 1, minus 3, we bring that 4 over then, and we've got it solved for y. Now y equals negative 3x plus 1. Make sure to read the directions carefully to see if they do ask you to actually change it to a specific form or not. So if you look at both these formulas, your point slope and your slope intercept that we just talked about here, these two formulas here and here both have a few things in common. They both have y values, they both have x values, and they both have this same variable m. that variable m, that's kind of the key to all of our equations, which is what we're going to ask you about here. Looking at our two formulas, what do they both have in common? Well, they both have m, and m, if you remember, that represents the slope. We talked about that slope at the very beginning of the notes. Just a quick refresher, I'm going to jump back to there. We talked about it and we said, here's the formula for slope. It's rise over 1, change in the y's over the change in the x's, or y2 minus y1 over x2 minus x1. And so the notes ask you a question back here. It says, if we're given 2 points, what should we find first? So sometimes I don't give you the intercept and I don't give you the things like that. So if you're just given 2 points, the first thing you want to find is your slope. That's the first thing that you need. So I'm going to write that down, because slope is necessary for both equations. So here's an example of that. It says, what is an equation of the line at the right? We look at this line. We're given an ordered pair and an ordered pair. With those two things, we're going to go ahead, we're going to plug them into our slope formula in order to have a slope so we can actually write this up. So remember, it's y2 minus y1 over x2 minus x1. All right, so this is going to be my number 1 ordered pair. This is going to be my number 2 ordered pair. So I want y2, I'm going to go grab the 5. I want y1, I'm going to grab that -1, and it's minus a -1, so it turns into a plus. x2 minus x1, well, that's going to be my 3. Minus a -2 is going to turn into a plus, and I end up with a slope of 6/5. So I've got my slope. Now I'm supposed to write an equation. So if I think from there, I've got two forms. I've got slope-intercept and point-slope forms. Because I wasn't necessarily given the intercept and I can't quite see it clearly there, I'm going to plug this into my point-slope form, which looks like this. Now, you do have two slopes to 2 points you can choose from to plug in. So technically on this one, there's 2 correct answers. I'm going to see if you guys can plug in your values correctly and then check to see if either one of yours match with mine. So pause the video and try to plug in your values here. So here you can see in red both of the versions. It just depends on which ordered pair I picked. In the first one, I used the ordered pair 3, 5. And in the second one, I used the ordered pair -2, -1. So there are 2 correct answers for this one in point-slope form. So those are your basic diagonal lines, your point slope and your slope intercept. We're also going to talk about this other type of a line, 2 lines, which are horizontal and vertical lines. So I'm going to sketch a quick picture over here for us to reference. I highly advise you put this in your notes. This is our coordinate plane. And if we think about like a horizontal line is going to look like this here. And a vertical line is going to look like this one here. And if we think about those lines for a second, our horizontal line, you can see that that horizontal value never changes, and your horizontal value is actually that y-intercept. So what is the slope of a horizontal line? We want to think about that. Well, the y value is changing, is staying the same, sorry, but the x value continues to change as we go through that. So horizontal lines, what I like to think is happening is that's when you're driving in a car. It's like when you're driving in a car in Nebraska, if you've ever driven through Nebraska. It's flat as a pancake, and there's really nothing to see. So the slope in Nebraska, the slope is actually 0. You can drive it, but it's really not that exciting, right? When we look at that vertical line, we're making a guess about that slope. Well, I think about trying to drive that. If I was in a little car trying to drive along this red line, I would not be in control of my vehicle. I wouldn't be able to drive that. And that slope is actually going to be what's called undefined. The reason why both of these have to do with how that slope formula would work, when you're looking at the vertical line, you're going to have some number divided by 0. Well, we know we can't divide by 0. That's why it's undefined. And for the horizontal line, it's really going to be 0 divided by some number. Well, 0 divided by anything is just 0. So that's kind of where those are coming from. So we're going to be asked to, I know that these have slopes, these are just 2 facts you should memorize, and then we're going to be asked to write the equations for these. So here it says, what are the equations for the horizontal and vertical lines? They're 2, 4. So if I'm looking at this, maybe I start with the horizontal line, that's right here. And I think about that horizontal line for a second, and I see that it has an intercept, a y-intercept of 4, and I notice every single point along there has a y value of 4. And every single one has a different x value. And really for horizontal lines, x continues to change like I said earlier, but y is going to stay constant. So because it has no slope, it really just becomes 0x, or 0 for your slope value, plus 4. Well, we know that 0 times anything is 0, so it really just turns into y equals 4 for your horizontal line. When we look at our vertical line, we look at that, we can see that every single value on there has an x value of 2, just like it does from that intersection, but every single y value changes. And we know that these have undefined slope, so we can't really plug it into this type of a form we did right there. But we notice the x value is constant. And so actually what the form looks like for a vertical line is just x equals 2. It's just x equals then a number. And so that's your vertical line. All right, you are asked now to write the equations for the horizontal and vertical lines through 4, -3, and then to think about that part B. So the video is going to pause here, try these 2 on your own, and then check with me. All right, so you can check your horizontal and vertical lines with mine. The last question says, can you write the equation of a vertical line in slope-intercept form? So if we just quick remember, slope-intercept form looks like this. It's y equals mx plus b. We know that on vertical lines, we don't really have a y value. We don't really have a y-intercept. And if we think about this slope, slope is undefined. There is not a number we can use for it. So this form, it doesn't work. And the reason why it doesn't work is because of that undefined slope. So I would say no, that the slope is undefined, so you can't put in a value for m. All right, and this is the end of lesson 3.7. This is part B. The goal was for you to graph and write linear equations.